There. She was there. It wasn't there.
Okay, kids, we are starting today the most fundamental part of chemistry. That's been a long time coming. This is titled Ionic Bonding. First is a definition of a chemical bond. A natural electrical attraction between the nuclei and valence electrons of different atoms that binds the atoms together. Definition: ionic bonding. The transfer or giving up of valence electrons resulting in an electrical attraction between cations and anions. Remember, cations are what?
Positive charge.
Mm-hmm. Anions, negative ions. Very good. Okay. Definition: ionic compound. A compound composed of positive and negative ions that are combined so that the number of positive and negative charges are equal. What does that mean? The sum of the charges?
It's coming neutral.
Mm-hmm. The sum of the charges. Thank you. On all correctly written formulas. Equals 0. Definition, binary ionic compounds. Compounds composed of two elements. Binary is a prefix that means two, okay? So these are compounds composed of two elements. A metal and a nonmetal. Underline metal hooked to a nonmetal. Okay, central heading. Rules for writing binary chemical formulas. Rules for writing binary chemical formulas. Okay, everybody up with me? Number 1. Write the symbol for the ions side by side. Write the symbol for the ions side by side. With the cation. Which again is the what ion? Which again is also a what? Metal. Remember, metals form positive ions. Okay? Always first. So what does that mean? The nonmetal anion is always bringing up the rear on the back side. Okay? Okay, so an example here would be Al, which is a metal. Its ionic charge is plus what? And oxygen is the anion, the negative ion, with a minus 2. Okay?
That's literally how you write that.
No. Yeah, this is just demonstrating how we're going to go through the process. That is not a correctly written chemical formula. It's a process of teaching you how. Okay, 2. Cross over the charges. We call it crisscross applesauce. Dorky, but it works. By using the absolute value of each ion's charge as the subscript for the other ion. Okay, I'm going to let you catch up with me. Okay, you see I have just a little bit of room, but that's enough to do what I'm going to do with you. So if you can keep it here on this with this number 2. Okay, so I'm going to rewrite this again. So AL plus 3, O minus 2. Okay? Second rule says to do what? Okay, now it says to take the absolute value. That means just the numbers with no charges. Does everybody understand?
Yes.
So the AL gets a what? And it is a subscript, kids. And the O gets a what?
3.
And the arrows point to where you're supposed to place them. Does everybody understand? Okay. Now then, to prove that this correctly written formula has no charge, we're going to do a little math. 2 times a plus 3 is what? 3 times a negative 2 is what? What does that equal? 0. So can you see that now on both sides you have the exact same numbers, just opposite in sign? So it will always equal what? 0. Now, the correct written formula is Al2O3. Questions?
So you can do that with any element and it should come out to 0 with their
Absolutely. Writing a chemical formula, ionic chemical formula, this is the way it functions. Okay? All right. Three. Everybody see me? Rule 3. Check the subscripts and divide them by their greatest common factor to give the smallest possible whole number ratio. Then write the formula. Okay, I'll let you finish that. Okay, now I'm going to take you back and we're going to look at this right here. Can you factor out anything between the 2 and the 3? No. This is the smallest whole number ratio. There's nothing to do there. Okay? Now I'm going to do an example that is going to cause us to do what it says in number 3.
Factor.
Okay, so let's look at Pb, which is lead, plus 4, and oxygen, negative 2. Can you already see that you're going to have a factor situation?
Yeah.
Okay. All right. So what do we do first? Crossover.
That 2.
2 and the 4. Okay. So we come up. Let's check our charges. 2 times 4 is what?
8.
And 4 times the negative 2 is equals 0. Okay, so we know that's correct. Okay? So this goes to the formula Pb 2O4. Now please make note, do I ever put anything up at the top after I have done my crisscross?
No.
No, nothing exists anymore at the top. Okay? All right. Now then, so if we divide both numbers by 2, we come up with what formula?
PbO2.
It's correct. And you can kind of look at it in a math sense. It's in its lowest reduced form, yes?
So if you have 2 numbers that you can divide by,
Then you apply
you
this.
don't have to divide them.
Yes. Okay? Most of the time you won't. Sometimes you will. Okay? All right. Number 4. Never write subscripts with a 1.
That's kind of like writing a number with an exponent of 1, kind of the same.
Exactly. All right. So, what does that mean? Just having the symbol.
Formula symbol.
That's right. Just having the element symbol means there is 1. Okay? An example. Let's do Na plus 1. Where am I getting all these ionic charges? You remember me having you write them on your periodic table? Cl is a minus 1. Now, looking at this one, you're going to see basically this is a 1-to-1 ratio, isn't it? How do I know? Because the charges are exactly the same but opposite in sign. Does that make sense? So a 1 here and a 1 here in the crisscross. Yes? Do the math. Plus 1 minus 1 equals what? Zilch. Now, you see these ones? Okay. So it goes to NaCl. Okay? Never write ones. All right? Okay. Central heading. Rules for naming. Binary compounds. Let me put it this way, binary ionic compounds. Number 1. Name the metal first using its element name. Number 2. Name the nonmetal using the root of the nonmetal. And put the suffix What is a suffix?
That's on the end of the word.
Like I and
Uh-huh. On the end.
Hey, what medical terminology go? I should know.
And put the suffix IDE on the end. Okay, I'll let you kind of process that information. Okay, examples. KCl. What is the name of K? Okay. Do you do anything to the name of the metal? Nope. Okay. Take the root of chlorine, which is chlor, and end it with IDE.
Chloride.
Mm-hmm.
What is potassium chloride?
It's another salt. All ionic compounds form a group called salts. Not just NaCl is a salt. It's one of a whole bunch of things called as salts. It's a group of compounds. Okay? CaO. What's the name of Ca? Calcium. Oxygen is ox. Exactly. Okay. Al2S3. Who's Al? Okay. S is who? Sulfur. So it goes sulf. Exactly. Okay. All right. Do you remember me telling you that we'll deal with the transition metals later? Well, guess what? Later has now come to now. All right. Transition metals.
Is this a heading or is this a
No, it's just a sentence. Transition metals will have a Roman numeral in the middle of their name indicating their ionic charge. I'm going to have to trade papers. I'm going to do 3 examples. Everybody finished? Okay, 3 examples. Finish up the notes. Example. Lead. Roman numerals. If you don't know your Roman numerals, you better get familiar with them. IV. V is 5. 1 in front means subtract 1 off of 5, so it is 4. Okay? Oxide. That is PB. We did that on the other page. PB4. O minus 2. Where'd I get the 4?
Oh, the PB plus 1, it's the plus 1.
This right here told me the charge of PB in this compound. Does everybody understand? That is the function of this, because you cannot get it basically from looking at the periodic table. The main group elements, group 1, 2, and the P block over there, which I call 13 or 3, 14 and 4, and so on through 17 and 7. Okay? You wrote their ionic charges. Does everybody understand? But you didn't write them for the transition metals, did you? No. Okay. So we know to do the crisscross. I'm going to kind of cut this short. We already know that it goes to what? I'm going to do it. I'm going to go all the way through. PB2, O what?
PB2, O4.
Which goes to what? Okay. Now, then, somebody please tell me again what the Roman numeral is telling you about the transition metal.
What's its charge?
It's ionic charge. Okay? All right, so let's do another one. Copper 2 chloride. Okay, if you look up on my periodic table, see the Cu, it's element 29. Okay, so Cu what? You got to talk in positive and negatives. Okay, chlorine is in group 7. Symbol is Cl. Everybody in group 7 is a what?
-1.
-1. Okay, crisscross. This is a 1, crisscross. This is a 2. Remember, leave all charges behind when you crisscross.
That's the smallest whole ratio.
Okay, so this is a +2. This is a -2, which equals 0. So you come up with what formula, kids?
Cu, Cl2.
That's right. 1 Cu, and Cl2. Questions? One more example, and we're done. So keep the paper that you picked up. We will do that tomorrow. It's not homework. Example. Last example. Iron. 3 nitride. Okay, iron is Fe, number is at 26.
Yes.
What is the Roman numeral 3 telling me? plus 3. Okay? Nitrogen, symbol is N. Look where it lives up there. Minus 3. Excellent. Okay, can you see that it's a 1-to-1 ratio? So 3, do the math, is a plus 9, minus 9 equals 0. And we will start leaving all of this business out, and we will simply cut to the chase with the crisscross. Does everybody understand? This is a teaching process today, and so you will not always do this. So what is my formula? It is. Okay, well, let's look at it as Fe3N3. Now what do I need to do? Okay, so it's Fe N. And we are finished.